Hello, this is Andy from Engineers Academy, and in this video tutorial we're going to be doing some practice tasks using Autodesk Fusion 360. Now in this particular video we're going to produce a 3D model, and that model is going to be of a mitre block. Now typically a mitre block is used for cutting 90-degree and 45-degree angles. So we're going to produce a simplified mitre block that would typically be moulded out of plastic. Once we've produced our mitre block, we're going to inspect that component to determine the overall volume of the model. And finally, we're going to assign materials to the mitre block so that we can determine the approximate mass of the mitre block. Now, the block that we're drawing is a simplified version of an actual component. And the reason why we've simplified this is so that we can practice some very basic operations within the Fusion 360 workspace. If you're accessing this video through the Engineers Academy study platform, then you'll also have access to an orthographic drawing of this component, so you can either follow the video and produce the component, or you can aim to produce the component using the drawing. I'm going to be using the drawing, and I'm going to produce the component in the hope that you can follow along and build the model for yourself. So the very first step then is to create a sketch of the front face of our mitre block. We need to choose a plane to sketch on. And with reference to the drawing, I know that the front face needs to be 300 millimeters long by 60 millimeters deep. So I'm going to sketch that now. As you'll notice, the dimension at the bottom, or the length, is currently highlighted. So that means I can edit that. So I'm going to type 300 for my length. I'm going to hit the tab key, and I'm going to type 60 or 60 millimeters for my height. Now when I hit enter, that sketch is now fixed in space. I'm going to click Finish Sketch, and I'm also going to click the Fit to Screen icon down at the bottom here. Next, I need to extrude the block through its depth. Now once again, with reference to the drawing, I know that the depth of the mitre block is 95 millimeters, so I'm going to use the Extrude tool. The outline of my sketch is highlighted, but if it wasn't highlighted, then all I need to do is click that sketch, making sure that the full area has been highlighted. Once again, my measurement is highlighted here. I can either drag my arrow, or I can simply type the value, 95 millimeters, into the box. Now I have the general outline for my mitre block. I'm creating a new body, and I click OK. Once again, let's fit that to screen. And we have the outside geometry for our mitre block. Now, as with anything in CAD, there's always more than one way to produce the same component. So I'm demonstrating how I would approach this task. If you're working from the drawing, you may well be able to approach this in a different way and still achieve the same outcome. So within our mitre block, we have a cutout, and the cutout comes out of the centre of the block like so. So what I'm going to do to create this is I'm going to sketch on the top face this time. So I'm going to specify Create Sketch, and I'm going to select the top face of my geometry. Now notice that the geometry has been reorientated in order for me to sketch on that plane. So I'm also going to fit to screen once again. So I'm going to create a rectangular sketch on the top surface, but at this point I'm not going to specify any dimensions. So I'm going to click my first point, and I'm going to click my second point. If you need to pan the drawing, you can do so, and hitting Escape will take you back to defining the second corner of your rectangle. So at this moment in time, this rectangle is underdefined. We need to specify some dimensions to fix this in space. Fusion knows that we've snapped to this edge here, and Fusion knows that we've snapped to this edge here, but it doesn't know the width or the position of the rectangle. So hitting Escape again to move out of the Pan tool, I'm going to select my Dimension tool. Now, with reference to the drawing again, we know that the distance from the rectangle edge here to the outside of the block is 15 millimeters. So I'm going to place my dimension, and once I left click to place my dimension, I have the option to type in the value of that dimension. And you'll notice that the sketch is updated accordingly. Now I'm going to do exactly the same on the other side. So I've selected my dimension tool, I've selected the edge of the rectangle, I've selected the outside of the block, I've positioned my dimension, and I've typed the value of 15. So now what we have is a fully defined rectangle in order to perform our cut operation. I'm going to finish the sketch. I'm going to rotate or orbit my object slightly so I can visually see the rectangle on the top face. And I'm going to select my extrude option once again. I'm going to select the sketch that I've just produced. Now, the important point to note here is that this particular extrude function needs to be a cut. So it needs to cut into the object and remove material from our block. So rather than new body, I'm going to specify cut. I'm also going to make sure that rather than the arrow pointing upwards, I need to make sure that the arrow points downwards. So I'm going to drag down into my object. And you notice that we can see from the preview that this is going to remove material from the block. I still need to specify my depth. Now, with reference to my drawing, I can see that this depth needs to be 45 millimeters. But I want to draw your attention to the fact that there's a minus sign at the start of this dimension. If the arrow was pointing upwards, then the dimension is positive, but downwards is negative. So when we specify this dimension, we need to ensure that we put minus 45 rather than just 45. Now when we click OK, we can see that our new object has that section of material removed. The next stage then is to include our cutouts, and the cutouts are where a saw would pass through in order to achieve 90-degree and 45-degree cuts. Now once again, there's a number of different ways in order to achieve this, but the way that I'm going to do this again is by performing a cut on my top surface. So I'm going to specify sketch. I'm going to select one of either of the two top surfaces, and again it won't matter which. And I'm going to fit to screen once again. Now we're just going to do one of these cuts at a time. There's 3 cuts in total, but we're going to do one at a time so that we can practice the operation. I'm going to start with the insert for a 90-degree cut, as that's the most straightforward. So I'm going to select my rectangle tool again. I'm going to pick an arbitrary start point and an arbitrary end point. Okay, so at the moment the position of this rectangle isn't defined. But I know from my drawing that the first edge of the cutout, which is going to receive the saw, is positioned 73 millimeters from this leading edge. So my first dimension then goes from the corner of the block to the corner of the rectangle. At present, that is specified as 70 mil, but I need that to be 73 millimeters. I also know that the thickness of the slot is 2 millimeters. So once again, I use my dimension tool. I select the first edge of the rectangle, the second edge of the rectangle, place my dimension, and change that to 2 millimeters. Now, if I wanted, I could specify the position of this corner of the rectangle or the overall length of the rectangle. But as I'm going to be using this to cut through the part, there isn't any benefit in me doing that at this stage. And you'll see why as we continue this video. So let's finish our sketch. Let's orbit this object so that we can see the top surface and the rectangle that we're going to use for cutting the object. We're going to extrude. We're going to select the rectangle for cutting. Now notice here that part of the rectangle is being cut off because it's intersected by the edge of our block. So we need to make sure that we select both of those rectangles. We know that we're using this for a cut operation. So we change from new body to cut. And we're also going to drag our arrow downwards so that we get a visual representation of how that cut's going to be performed. Now I know from the drawing that that cut depth needs to be 47 millimeters, but notice once again that we have a minus because we're cutting into the object. So I'm going to change that to minus 47. I'm going to click OK. And now if we orbit that object, we can see that the cut is the full way through the block, as well as leaving an impression of 2 millimeters on the bottom surface. We have 2 more cuts to perform. We need a 45-degree cut that goes across the block in this direction, and a 45-degree cut that goes across the block in this direction. And those 2 cuts are going to cross in the very center of this face. Now, once again, there's lots of different ways in order to do this, but I'm going to choose to sketch on the top face once again. So create sketch. And we could either pick this top face here or this top face here. I'm going to pick this top face. Fit to screen. And now we can go ahead and draw our 45-degree cut. For this particular cut, I'm going to use the line tool. I'm going to place my first point and I'm going to draw my second point. Now what we notice as we do this is that we have a length specified. In this instance, it's 143 mm at present. And if I tab, we also have an angle. Now we could either work out what angle we need this to be in order for this to sit at exactly 45 degrees, or we can dimension this angle afterwards. So let's draw the line, and again I'm going to draw it oversized. I'm going to hit escape to come out of the line tool, and I'm going to add a dimension to specify that angle. I can choose the edge of my block here and the line here, and we know that this needs to be 45 degrees. So let's place our dimension, 45, and enter. The other dimension we know from the drawing is that the start of this particular cutout needs to be 120 mm this time from the leading edge of our mitre block. So let's add that dimension. We're going from the corner of the block to the line, and it's 120 mm. So that first line of the cutout is now fully defined. What I'm going to do to speed things along is I'm going to include the second cutout, which is at 45 degrees in the opposite direction across the block, but the starting point is going to be in exactly the same position. The reason the starting point is in exactly the same position is because these two cutouts need to intersect at the center of the block. So I'm going to take my second line. The starting point is in the same position as the previous line. We can draw this at any angle once again, but because the dimension is showing as a positive angle, I'm going to tab across, change it to 45, and now that dimension is locked in. Now, in order to create our cutouts in these two directions, we once again need to specify that the thickness of this slot is 2 mm. But note that the dimension of 2 mm needs to be offset at the 45-degree angle. Now, the easiest way to perform this is using an offset function. So if we select offset, and if we select the first line first of all, then we notice that we can offset the line that we've produced by any given distance. I'm going to drag it in this direction because I know that 120 mm is the start of my slot, and then the slot needs to go 2 mm away from that point. I'm going to change that to 2. I'm going to hit enter. And I'm going to repeat exactly the same for the other line. I click here, 2 mm, like so. Now we need to be a little bit careful here because we don't have closed sketches. We have two lines, but those sketches aren't closed. So what we need to do is close each of those off so we have an enclosed chain or an enclosed rectangle, and then we can use each of those to cut into our block. I'm going to zoom in. I'm going to move fairly close so that we can see what's happening here. I'm going to pan on this edge first of all, and I'm going to select my line tool, and I'm going to connect the start and end of my rectangle. I'm then going to hit escape. I'm going to pan to the other side, and it appears to have offset in the wrong direction. Now this isn't a huge problem because we can actually edit this sketch. If we find the dimension and we double click on that dimension, we need to change that from 2 mm to -2. We can see that the direction there was wrong. When we change the dimension, the sketch updates accordingly. So let's continue with the sketch. We're going to close this profile. We're going to pan to the top. I'm going to close this profile. Now once again, it doesn't matter that these rectangles are oversized because we're using them to perform a cut operation rather than a join operation. Okay, so I'm now satisfied that we have our two rectangles that need to be used to cut into the block, and I'm satisfied that they are both closed profiles. So I'm going to click Finish, and I'm going to do Extrude Cut. Now you could do each of these individually. You could cut the first slot and then the second, but I'm actually going to do all of this at once. I need to make sure that all of the profile is selected for both of these cutouts. So I need to go around and carefully select all of the parts that I'm going to use for cutting, like so. I'm also going to select this part here, as I'm not quite sure where that rectangle intersects with the block. Okay, as before, let's change this to a cut operation. Let's orbit so we can get a visual representation. And let's drag this down through our block. Now the depth of this is the same as the previous cut. The depth of the previous cut was 47 millimeters. But once again, taking note that we have a minus here, we have minus 47 millimeters. And there we can see the visual representation of our cut. I'm going to click OK. Now, once again, we can see that those cutouts go right the way through the block. We can see that it's left the 2 millimeter indentation on the bottom surface. Therefore, I'm happy that we've created all parts of that mitre block as expected. Now, the final operation that's specified on our drawing is that we need to shell this object to 4 millimeters. Now, if you think of an injection molded component, it's a very thin layer of plastic. So at the moment, we have a solid block of plastic, which isn't necessary. So let's perform a shell function, and we're going to shell from the bottom surface. What this means is the bottom surface is going to be taken away, and we're going to create a shell out of the rest of the geometry. So up here we have our shell function. It's going to ask us which face / body we want to shell, so we need to make sure we pick the bottom surface, like so. And you have the option to shell inside or outside. Now we're going to specify inside because we want to keep the outside surface and cut material out from the inside. We're going to shell this to a thickness of 4 millimeters. We can see the preview there. That's exactly what we're looking for. Making sure our cutouts still travel the full way through the object. Okay. And once we're happy, we can click OK. Now there we have the completed geometry for our mitre block. I mentioned at the start of the video we was going to inspect this and we was going to assign some materials to it. So the first thing we're going to do is we're going to inspect our mitre block to determine the overall volume of material used to produce this component. If we expand our bodies menu, we only have one body, and that's our mitre block. If we right click, we have an option here, Properties. And under the list of properties, we have the volume of our mitre block, 3879 times 10 to the 5. All that means is that our decimal place moves 5 to the right. So the overall volume of this block is 387900 cubic millimeters. So effectively 388,000 cubic millimeters. We could change the units of this if we wished, but at least it gives us an idea of how much material makes up that object. But what we're more interested in is the overall mass of this object. Now, at the moment, we don't know what material is specified for our mitre block. So once again, we need to select the body and we need to go to physical material. Now, for this particular mitre block, we're going to specify the material as ABS polymer, which is a type of rigid plastic. So if we go to our plastics list, and you'll notice that the very first plastic there is ABS plastic. So if we drag the ABS plastic and drop onto our object, we notice that the physical appearance of our block has now changed. We've assigned the material to that particular object. Let's close our menu. And once again, let's right click and click on Properties. And what we see this time is our volume is unchanged, as you would expect, but we also have a mass specified, 411.19 grams. So the overall mass of our ABS plastic Mitre block is 411.2 grams to the nearest one decimal place. So I hope you found this video useful. We've seen how we can perform various operations using Fusion 360, first of all to create a solid block, and how to perform additional operations such as extrude cut, as well as applying dimensions, ensuring that the dimensions and positions of all of our features are correct. We've also looked at how we can inspect the component to determine things such as volume and mass, as well as how to assign specific materials to a given component in Fusion 360. Thanks for listening.